Dear students, now that we have learned the basic gates, we shall now look into some more complicated combinatorial circuits. So let us have a look at the 2 to 1 multiplexer. So over here you can see that this multiplexer has two input pins labeled as 0 and 1, and this one that you can see over here is mentioned as the control signals, and the smaller edge over here represents the output signal. So what does a multiplexer do? A multiplexer is like a switch. So based on the status of the control signal, the multiplexer chooses between either 0 or 1. If the control signal is set to 0, then the output of the multiplexer is switched to the input 0. So whatever appears at 0 comes out at the output. If the control signal is set to 1, then the input signal at port 1 gets mapped directly to the output. Let's see a small example of how it actually behaves. Over here, let me give a toggle input at the 0th pin, and let me choose some other toggling over here. Rather than toggling, I would choose a clock so that the difference in the activity is easily observed. Here I choose another toggle input for the switching, and I use the LED for visualizing the output. As you can see over here, I have set the control signal to 0. That means that whatever is being displayed or whatever is being input to port 0, that gets mapped to the output. Over here, the input is at bit 0, so the LED is off. Now you switch it on, it becomes on. But interesting thing is that there are lots of variations happening at port 1, but that is not at all reflecting at the output. So if you see that I am manually changing the input at port 0 as per my choice, so that's being reflected at the output. Now let me toggle the input at control signal to 1. So you can very well observe that now, because the clock is toggling at the signal 1, the LED is also toggling in the same manner, because the multiplexer switches to port 1 as the input, and irrespective of whatever I do at port 0, it does not reflect at the LED or the output. Hence, multiplexer can be chosen as a good switch whenever you want to choose between two streams of data. Now that we have learnt about the 2 to 1 multiplexer, let's build a 4 to 1 multiplexer. So what is the duty of a 4 to 1 multiplexer? A 4 to 1 multiplexer takes in 4 ports as inputs and gives a single one as an output. But then we have a 2 to 1 multiplexer over here. So how do we construct a 4 to 1 multiplexer from this 2 to 1 multiplexer? Let's see. So we create a layer of 2 to 1 multiplexers over here, and then we have another multiplexer over here, as you can see. So the first two multiplexers in the first column work as the primary inputs. So over here, this one stands for the 0th input, this one will stand for the first input, this one will stand for the second input, and this one for the third. 0 1 2 3. I have told this in a binary or digital format because digital numbers start from 0. So essentially you have 4 inputs over here. Now among these 4 inputs you have to choose one of them, but then we can't choose them directly, so we choose step by step. So note that since you have 4 inputs over here, you need log4 base 2, that is 2 select lines or 2 control signals to decide which signal to choose, because you have four input lines over here. So 0 0, let's suppose the select lines are 0 0, then this one will be chosen. 0 1, then this one will be chosen. 1 0, then this one will be chosen, and 1 1, then this one will be chosen. The higher bit, that is whether it will be 0 0 0 1, if the higher bit or the MSB is 0, then I shall be choosing this multiplexer. Okay, this multiplexer which is attached to 0 over here. Now the lower, if the higher bits MSB is 1, that is 1 0 1 1, then I will be choosing the lower multiplexer. So you see, this control signal should be my MSB or the most significant bit. I attach the toggle group over here, and now the LSB will be chosen by the individual multiplexers over here. So they will drive the same signal. All right, so let me give signals of my choice. I give a ground, I give a high voltage, and I also choose a clock. So you should be careful about such short circuits which might take place when you're designing the circuits. Alright, now let's put the output over here. Let's say I want to choose the first signal over here. That should be what? That should be 0 0. So you see, 0 for the MSB, 0 for the LSB. When the LSB is 0, then this multiplexer chooses the toggle bit, and this multiplexer chooses the high VDD or 1 voltage. Then both of them are selected. Now the MSB being 1 chooses only this port, that is the output of the first multiplexer, and that's why you can see over here, since this is 0, it remains fixed to 0, and when I click this and toggle it, then the LED starts glowing. Now when I want to choose the 0 1, then this one will remain 0 because I have to choose the first multiplexer only, and 1 implies that I have to change this to 1. So you see over here that I have the ground signal over here, and this one doesn't change. So even if I switch these toggle buttons, then you see that this LED does not glow. That means it's confirmed that the ground signal is flowing. Now I want to choose 1 0. So 1 0 meaning that this second multiplexer over here is being chosen. So 1 means I am choosing this, and 0 implying I am choosing this VDD. So even though this toggle bit input is also being chosen because the first multiplexer, the 0th port is being toggled, but then that is not showing up in the LED. Now when I want to choose 1 1, I am obviously choosing the second multiplexer, but then the second port of the second multiplexer is being chosen for the lower one, and for the upper one the ground pin is being chosen. But as I have 1 in my MSB, I have the clock toggling being shown up in the LED. So that's how a 4 to 1 multiplexer can be constructed from a 2 to 1 multiplexer. Now an activity for you would be to construct an 8 to 1 multiplexer using the 4 to 1 multiplexer.